Okay, we're going to wrap up this module. The last two things that we're going to talk about is gyroscopes and accelerometers. So when we are designing a robot, sometimes we need to know the orientation, just like what we deal with the transformation matrix. We would need to know what is my current orientation, what is my current coordinates. So we might need to know what is my current angles of round, yaw, and pitch. So when we need to know those kind of information, we are measured from individual link. Gyroscopes is going to let us to decide those kind of information based on the measurements. Accelerometers is used to measure the force based on the acceleration. So this is important property that we need to measure when we are dealing with robotic devices. Let's talk about accelerometers. The measure is the inertial force generated when the mass is affected by the change of velocity. So the force can change the tension of spring. It may be a deflection of a beam. It may be a vibration frequency of a mass. So depending on how you design those kind of things, it can be a little bit different. Normally, when we try to do accelerometers, we also measure the frequency. So when we try to measure something in high frequency, that can be a problem because most of the accelerometers are mechanical ones, so it cannot detect anything in high frequencies. However, if you are trying to find something extremely low frequency, accelerometers also has its own limitation because if you try to look for something that can measure like 2 hertz, 0.5 hertz, then it's going to be a little bit difficult for us to find those kind of sensors. The structure of accelerometer is simple. We got a spring, we got a damper, we got a mass. So the equation of motion is going to be something like this. When the accelerometer is moving at a single direction, let's say it's moving upward. So due to the acceleration, the mass is going to be moved to this direction, and the spring is going to be extended. The damper over here is going to have some movement downwards. So the output over here is going to have some different index. So by knowing the position over here and knowing the velocity of the changing rate, by knowing the acceleration of this changing position, we should be able to come up with the equation of motion of this mass. Okay, so with this kind of configuration, then we should be able to use some symbol circuit to identify what's going on over here in the chamber. So we can determine what is my current acceleration or my current position or what is my current velocity. By either differentiation the information or integrate the information, we get the other two information that we are not measuring. So those are very common properties that we can measure using accelerometer. Accelerometer, the price of accelerometers varies from few dollars to few $100s. If you try to deal with robot and you are using something that just for quick check, then you probably can buy an accelerometer, maybe about $10. However, keep in mind when you are using those kind of sensors, the resolution might not be good enough for you to do accurate control. So when you have this kind of problem, you probably need to use data fusion and have more sensors, few more sensors in your system. So fuse all the information required, then generate something more reliable or more accurate. The other thing is that we might want to use gyroscopes. For gyroscopes nowadays, they probably provide 6 or 10, 9 degree of freedom, and they might fuse together automatically since they sometimes they have a very small processor included in the sensor board, and in many cases this kind of sensors is going to generate the Euler angles, and we can use those information directly. This one over here show on the slide. This one costs only about $10, and this one has 6 to 9 degree of freedom, and it generate Euler angle and raw data format for everything. So we can just use those kind of things to detect the angular information and the coordinate information in terms of linear movement and angular movement. So this can be convenient for us to detect the angular representation at individual links in our robotic system. The other thing we might want to The other sensor we might need to use is GPS. If we are using uh, uh, mobile robots, position is going to be one important thing that we need to consider because we need to know the position of a robot all the time. GPS sensor can give us this kind of convenience. There are 24 satellites on the sky that is going to tell us what is my current location. It's the same idea uh, as the GPS sensor you use in your car. So if you are using GPS sensor on your robot, you can move everywhere and get the accurate measurement based on how many GPS signal you can see from the sky. Sometimes you might be able to see 2 or 3 because it's cloudy. Sometimes you might be able to see 7 because the weather is the sky is clear. So when we have those kind of measurements, it's going to have latitude, longitude, and altitude, all the information. So we should be able to detect what is my current position. If you need to have the mobile robot to travel through a soccer field, this can be an important sensor that we might need to use to detect what is the current position. However, keep in mind, this is not always something you can use in a robot. For instance, if you send a mobile robot to the Mars, or you send your robot to the moon. We do not have a GPS satellite for those two planets. So you might need to consider other alternative measurement to detect what is your current position. But if you just try to design some robot on Earth in your backyard or in your front yard to do some kind of mall job, then GPS can be a good sensor to complete your application.